Welcome to part 2 for adding and subtracting with unlike denominators. Please make sure you've watched the first video that really concentrates on the concrete, building concrete understanding with adding and subtracting with unlike denominators, and here we're going to move into the representation, into the algorithm. So just want to remind you that in 3rd grade students did work with equivalent fractions with models. 4th grade they worked with it to help find common denominators, and they would use that sometimes as they were even comparing fractions. Also in 3rd grade they partitioned number lines. They were able to take a line and partition it into either 3 parts or 4 parts, 8 parts. And then in 4th grade, they worked with multiples and equivalent fractions. So we really want to build off all that and kind of pull it together and help them see how that helped lay the foundation for what they're going to work on now with adding and subtracting unlike denominators. So we're going to start off with 3/4 plus 1/3. And we're going to kind of go back to our fraction bar pieces, which we talked earlier about how it's the beginning of a linear model. And we're going to connect that to how we can use that to draw a number line. So once again, this is our whole, and once we have these flipped over, and students have to realize these, like I said, these do have 1/4 and 1/3 on the other side, but having the students flip them over really makes them reason about which ones are the thirds and fourths, and they have to play around with it instead of it just telling them. So I've got my whole, and then I've got my fourths and my thirds. So I want to add 3/4 and 1/3. So what I'm going to do is I'm going to use these to help me draw a number line. So I've got my fourths, and I'm going to draw a line right below there. And I'm going to use these to help me section it off into my unit fractions of fourths. So then my 0, 1, and this is my 3/4. So then I'm going to come up and I want to draw another number line. So I'm going to have a double number line that's going to help me with my thirds. And I can see that I've got 3/3 equal to my whole. And once again, I'm going to use that to help me partition it into thirds. And I'm looking at 1/3 here. So once again, we also want to estimate. It's very important to estimate and help students reason to determine if their answer is going to be correct. So if I'm looking at 3/4, which is almost a whole, and I'm going to add on 1/3, which is almost a half, so my answer should be between 1 and 1.5 when I'm done. All right, so I'm looking here and I've got 3/4 and I've got 1/3. And I want to start thinking about, if I look here, where is a common denominator before my thirds and my fourths. So if I look at my thirds here, I can go down and I can see that I've got 6, 9, and 12ths. And then if I go to my fourths, you can see you have 8 and 12ths. So 12ths is what would work for both of these. So what I want to do is I want to think about what times 4 would give me 12, and that would be 3. So I want to go through and break each of these fourths into 3 parts. And then I want to think about 3 times what would give me 12, and that would be 4. And so I want to break each of the thirds into 4 parts. Okay, so then I can see that now both of these are broken into 12ths. 4, 8, 12, 3, 6, 9, 12. So when I look at that, now I can see 3, 6, 9 12ths. So 3/4 is the same as 9 12ths plus 1/3, which is 4 out of 12. And then I can see that that would give me 13 12ths. When I think of 13 12ths, I can think of it as 12 12ths and 1 12th, which would equal 1 whole and 1 12th when it's simplified. 1 12th can't be simplified any further because there are no common denominators between factors between 1 and 12 other than 1. All right, we're going to now move. All right, so we just looked at how to add on a number line, how we connected from the linear bar models to the number line. So now we're going to look at and kind of progress forward a little bit where they should end up finally with number line. Remember, for adding and subtracting, the standard states that they need to be able to use area models and number lines. So this is something they definitely have to master. So we have 6.5 minus 2 and 2/3. First of all, we want to estimate again. So if I go and I start thinking here, 6.5, that's almost 7. and 2 2/3 is almost 3. So 7 minus 3 should be around 4. So my answer should be around 4. That's also going to help me with when I draw my number line. I'm not going to need to draw a number line all the way back to 0. I really can probably stop between, go from 3 to about 7. So I'm going to begin drawing my number line. And so I'm going to put my whole numbers first. A little bit wider, but that's fine. So I'm going to represent 6 1/2. So 6 1/2 is going to be in the dead center between 6 and 7. So what I'm going to do is, remember, they already have knowledge, and by this point throughout this unit, the students should be very familiar with finding common denominators. So if I list my multiples of 2, 2, 4, 6, 8, and I'm just really going to list the first 4, see if any match up, and then 3, 6, 9, and I can see that 6 is a common denominator for both. And that's really simple because 2 times 3, but we'll look at one later where maybe you can't, there's easier common factors or multiples than just multiplying the two denominators together. So I have 6 1/2 represented here, and then I'm going to take away 2 2/3. So what I need to do is think about finding a common denominator for both of these. And I'm going to use 6 as my common denominator. So if I think of 6 1/2, and if I multiply 6 1/2 times 3 to give me a denominator of 6, and that's going to give me 6 3, 6. And then if I take away 2 2/3, if I look at finding a common denominator for that, I'm going to multiply by 2 here, and that will give me 2 4, 6. So I'm going to be subtracting 6 3, 6 from 2 4, 6. Now if I go back up to my number line, I really need to think about breaking it into 6 parts between each whole number. So I'm going to go back and do that. I had 6 1/2, so I'm just going to break on this side each part into 2, and that gives me 1, 2, 3, 4, 5, 6. That's broken into 6 parts there. So I'm going to break it into half, and 2 on this side, and 2 on this side. And I'm going to continue that down. All right, so now I've got 6 3, 6, which is here, and I'm going to take away 2 4, 6. I'm going to go ahead and take away my whole numbers first, and I know that that's going to be you know, the halfway mark. So I may want to think about that and realize that that's going to be my half, that's going to be my half, because that's 6 1/2 there, or 3, 6. So I'm going to take away 1 whole, which is going to put me at 5 1/2, or 5 3, 6. And then I'm going to take away my second whole, which is going to put me at 4 1/2, or 4 3, 6. Now I'm going to take away my 4, 6. So this makes it really easy. I can just jump back 1, 6, 2, 6, 3, 6, 4, 6, which gives me a difference of 3 and 5, 6. And that cannot be simplified because there are no common factors of 5 and 6. All right, so let's move on and look at the area model. Now we have here an area model. We have 1 1/3 and 1 3/4. And so I've kind of gone on over to the side and started thinking about my multiples. Once again, I'm not listing, you know, all the way to 3 times 9. I'm just going to do maybe the first 4 or 5 and see if I have anything in common. So I can see that I have a 12 in common for each of these. So if you think back to the video before where we used the parchment paper and we were adding 1/3 and 3/4, and we kind of combined these to help us determine that a common denominator would be 12. So that's kind of the same idea we're going to take here. And so what we did is we took the 3/4 and we also divided it into thirds. And so we also took the 1/3 and divided it into 4. So we're going to take that idea and connect it here. So I have 1 1/3, and I need to think about if I want a common denominator of 12, then I need this to be broken into 12 parts. So if I think about it's the 4th multiple, then I need to break the thirds into 4 parts. So that would be 1, 2, 3, 4 parts there. All right, and so then I can see that that is 1 4/12. Now I'm going to come over here and I'm going to see that it was the 3rd multiple. So I'm going to break it into 3 parts. 1, 2, 3, and that will give me 1 9/12. Now, if I can think about taking 3 of these 12ths and putting them over here, that would really fill that up and give me another whole, and then I'm going to have 1/12 left over. So that's some of that reasoning. So that will then give me a hole and a hole is 2 holes, and then 4 and 9 is going to give me 13/12. And remember, we just said that if I imagine these 3 pieces coming here, that's going to give me another hole, which changes my 2 holes to 3 holes, and I would have that 1/12 left over, which is the same thing of thinking of this as 13/12 is 12/12 and 1/12. Put that together for 3 holes, and then 1/12. Once again, it can't be simplified because there's no common factors of 1 and 12 other than 1 itself. Now, if we go back up here and think about our estimating, 1 and 1/3 would be about 1, and 1 3/4 would be about 2. So 1 plus 2 should be about 3, and we're just a little over 3. We're only 1/12 away from 3, so that worked out well. Another one here to look at is 1 2/4 plus 3/6. Now, remember in the other video we talked about reasoning. This is one that students can really reason with too, because if you think of 3/6 as a half, and we know that 2/4 is a half, then I could really say that 1 1/2 plus a half is 2. So I really didn't have to do any work there. I was able to reason that out. So you want kids to, to offer them opportunities to really think through that. I could not have done that here. It wasn't going to be that simple. But you want them to realize that. When is that going to work, and when is that not going to work? Now, with the last one we did, we were working with denominators of 3 and 4, which the only common factors or multiples was going to be, or the smallest was going to be 12, and that's 3 and 4. But if we look here, we've got 4 and 6, and so that would give us 24. But we want to maybe see if there's something smaller to work with than 24. So if I go over here, and once again I list my multiples, 4, 8, 12, 16, 20, 6, 12, 18, I can see that 12 is a common multiple for both of those. So what I want to do is I want to look at my 1 2/4, and I know it was the third, the 12 is the 12 is the third multiple. So what I want to do is go through and break each 1/4 into 3 parts. So I'm just going to do that all the way down. And once again, that connects back to our parchment paper when we did that. And the same thing on this side. So now I have 1 3/6, which is a half, which is the same as 2/4, which was a half. Now 5, 6, I can see it's the second multiple, so I'm going to go through and break each of these 6 in half. And then I can see 2, 4, 6, 7, 8, 9, 10 12ths. Now one thing I can do is I can realize I've got 2 12ths over here missing. So if I can imagine these 2 12ths coming over here, that would give me another whole, and then I'd have 1, 2, 3, 4, 5 12ths. No, I did that wrong. Sorry, 1, 2, 3, 4 12ths. So let's see if that works out. So I have 1 6/12 plus 1 10 12ths, which is going to give me 1 whole. I know that if I move 2 of these over here, that's going to give me another whole. So that's going to be 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. 6 plus 10, 6 12ths plus 10 12ths is 16 12ths. And like we just said, we know we can get a set of 12 12ths because I can move these 2 over here. And that leaves me with 4 12ths. And so then that would leave me with 2 wholes and 4 12ths. Now, if I start thinking about common factors of the 2, I know that 4 can also go into 12. So if I divide by 4, then that will give me 2 and 1/3. And it can't be simplified any further because there's not any common factors of 1 and 3 other than 1 itself. All right. So now that we have worked with the area model and number line, which are 2 strategies that are specifically named in the standard, so those are definitely things that the students need to master at the 5th grade level. We are also going to work with the algorithm because this is going to help them to be successful in 6th grade as they move there with adding and subtracting fractions. All right, so we have 6 1/2 minus 2 4/5. So once again, we want to estimate. We can think of 6 1/2 is almost 7, 2 4/5 is almost 3, and 7 minus 3 is about 4. So we should have a difference of 4 or around there when we are complete, when we're finished solving the problem. All right, so we're going to use the algorithm. We have 6½ minus 2 4/5. One of the things we hope the students by now have really recognized is they have to have a common denominator. So we see that we have a 2 and a 5. So if we come over and list multiples for 2, we have 2, 4, 6, 8, 10, and then multiples of 5, 5, 10. And I can stop here because I can see that 10 is going to be a common multiple. And I can see also that 2 times 5 would have been 10. But let's say that maybe these had been different and we could have sometimes found something smaller like we did for the 6 and 4 earlier. All right, so now I'm going to find a common, I'm going to get equivalent fractions for 1/2, and I'm going to multiply by 5. And that gives me 5/10, so 6 and 5/10. Minus, I'm going to get a common, equivalent fraction for 4/5 by multiplying by 2, which is going to give me 8/10. So 2 and 8/10. Now I have my common denominator, but I noticed that I cannot take 8/10 from 5/10. And we know that when students worked with even subtraction, they struggle with knowing or remembering to regroup. So let's look at the number minus 29. When we look here, we can see that we cannot take 9 ones from 2 ones. So what we did is we had to go to our tens place, and we would borrow a 10 and bring over a 10. So we're going to do the same thing here. I cannot take 8/10 from 5/10. So I'm going to borrow or regroup from my 6 wholes here. So I'm going to think of 6 wholes as 5 wholes and 10/10. And I'm going to bring that 10/10 here to my 5/10. So now what I'm going to do is just like over here, let's go back to our whole numbers. Let's kind of think back to something simpler. When I brought over my 10 here, I did not get rid of my 2. I had to add these 2 together, which then gave me 12 ones. So over here, when I bring over my whole, so this is a whole, and I'm going to add 10/10 and 5/10, which is going to give me 15/10. All right. So now I'm able to take 8/10 from 15/10, which is going to leave me with 7/10. 2 wholes from 6 wholes is going to leave me, with 5 wholes, because I regrouped that. Need to mark that out, put that here. 2 from 5 will leave me with a whole of 3. So 3 and 7/10. 7/10 cannot be simplified because there are not any common factors of 7 and 10 that will help us to simplify that. And remember, our estimation was around 4, which 3 and 7/10, I'm only 3/10 away from 4. So that should be a reasonable answer.